Welcome in the sixth section of our course. In this section, we're looking at the distributed models, so particularly we'll try to understand why using Spark underneath for our deep learning processing is very fast. We know that deep learning for J library uses Spark underneath, so then we'll try to understand the reasons why. So we'll start from configuring Spark for a hard data distribution. Next, we'll be fetching input set into distributed dataset using Spark API. In the third video, I'll be creating training master that supervises computations on the workers. Finally, we will be evaluating speed of distributed training using Apache Spark. This is a first video in which we'll be configuring Spark for high data distribution. So we'll start from looking at data partitioning in Spark engine. Once we will understand that, we will understand partitioning, and finally we will implement our custom partitioner. So let's start from this simple test case. We can see that I have a class that's called Spark for high data distribution. And we will write a test that it should use custom range partitioner. So let's assume that we have a keys with values list. So we will create an array of user transaction. Every user transaction has a user ID and amount. Once we have an array, we can create that in a Spark using Spark parallelize. But we will leverage here a Spark context that is created here. So we are creating a Spark context with master local and getting or creating that context. If you will specify here a star, it will take as many cores as you have on your computer. Also, we can specify remote here if you want to. So once we have our list, we can parallelize it and we will create a data. Data is an RDD of user transaction. So this is a resilient data distributed data set. It means that it can be processed by multiple workers, multiple physical nodes instances. Once we have that, we are keying everything by the amount. So then we will get an RDD that is of the pair of int and user transaction because amount will be used as a key. So it is very important because using that we can leverage the data locality. So every key that is the same will go to the same physical node and data will be processed faster. But to assert that, we need to have a partitioner. So default partitioner is a hash partitioner that uses hashing, but we want to use a custom range partitioner. So we can use a partition by method that will leverage a custom partitioner, and we are calling it custom range partitioner and specifying ranges to which we want to partition our data. So basically, first partition is from 0 to 100, second one is from 100 to 10,000, and last one is from 10,000 to 10 million elements. So let's look at the custom range partitioner class. So it implements the partitioner interface from Apache Spark, and we need to supply two methods. First one is number of partitions, and it is equal to range size, so will be 3 in our example. And next one is get partition. So for the specific key, we need to return the index of the partition. So we can firstly check that key should be instance of integer. If it's not, we are showing that this partitioner doesn't support integer. Then we are taking a key as an instance of integer. Then we can take a last index where. So this will iterate over every range that we pass as an argument here. If our actual value that we are searching for, so our k integer that is passed here, is higher than first part of the range and lower than second part of the range, so if it falls in the, for example, 0, 100, then we are just returning that index. Then if not, we are scanning next one, and finally we are just returning the index for that specific key. So lastly, we could get a proper partitions for every element data. So let's start this test and see results. We can see that for key 1,000,001, it returned the 2 because it is 0, 1, 2, so it falls in that range. Then for 100, it returns first one, for 4, it returns 0, and 10 also 0, 0. So we leverage the proper partitioning scheme. And what does it mean for the performance consideration? It means that every data that is within that range will go to the worker 2 Every data that has 100, it will go to the worker 1, and the next, last elements to worker 0. So we are able to parallelize computation properly.